American engineer Percy Spencer developed World War II radar technology that helped detect Nazi airplanes, but it soon had other surprising applications. One day in 1945, Spencer was standing near a radar instrument called a magnetron, a device that produced high-intensity microwaves that could reflect off planes. Suddenly, he noticed that candy bar in his pocket had melted. He exposed other things to the magnetron, and sure enough, popcorn kernels pop, and eggs, well, exploded onto a colleague. Soon after, the first microwave oven became available, operating using the very same technology. So, how does it work? All light energy travels in waves and oscillating electromagnetic fields. These oscillations span a range of frequencies comprising the electromagnetic spectrum. The higher the frequency, the more energetic. Gamma rays and X-rays have the highest frequencies, microwaves and radio waves the lowest. Generally, light oscillating electric fields exert forces on charged particles, like the electrons in the molecule. When light encounters polar molecules, like water, it can make them rotate. Their positive and negative regions are pushed and pulled in different directions. The frequency the light is traveling at also determine how it interacts with matter. Microwaves interact strongly with the water molecules found in most foods. Essentially, they make the molecules jostle against each other, creating frictional heat. Household microwaves ovens are fitted with cavity magnetrons. When you activate a microwave oven, a heated element within the magnetron will eject electrons, and strong magnet forces them to spiral outwards. As they pass over the magnetron's metallic cavities, the electrons induce oscillating charge, generating a continuous stream of electromagnetic microwaves. Generating a continuous stream of electromagnetic microwaves. Metal pipes direct the microwaves into the main food compartment. When they bounce off the metal walls, they penetrate a few centimeters into the food inside. When the microwaves encounter polar molecules in the food, like water, they make them vibrate at high frequencies. This can have interesting effects depending on the food's composition. Oil and sugar absorb fewer microwaves than water, so if you microwave them alone, not much happens. But when microwaves encounter a marshmallow, they heat the moisture trapped within the gelatin sugar matrix, making the hot air expand and the marshmallow puff. Butter is essentially a suspension of water droplets in fat. When microwaved, the water rapidly vaporizes, making the butter melt quickly, and sometimes a bit violently. So, microwaves heat molecules mechanically through friction, but they don't alter them chemically. Soup heated in microwaves is molecularly indistinguishable from soup heated using the stove or oven. The term microwave radiation can be alarming, but in physics, radiation simply describes any transfer of energy across a gap. High-frequency ionizing radiation may be harmful because it can strip electrons from molecules, including DNA. However, microwaves aren't energetic enough to alter chemical bonds, and microwave ovens are designed to prevent leakage. For safety and efficiency's sake. Nonetheless, to totally limit exposure, experts recommend simply standing a few feet Experts recommend simply standing a few feet away when a microwave oven is on. Microwaving metal is dangerous though, right? Well, it depends. Metals aren't conductors, meaning the electrons are loosely bound to the atoms and move freely in response to electric fields. Instead of absorbing microwave radiation, the metal's electric Instead of absorbing microwave radiation, the metal's electrons concentrate on the surface. leading to high voltages at sharp edges, corners, and small gaps. This includes areas between the creases of sheet aluminum foil, the plunge of pork, and the metal objects and microwave oven's metal balls. Sometimes voltages get high enough to strip electrons from the surrounding air molecules. This electrically charged gas, or plasma, may then form lightning-like sparks and grow as it absorbs more microwaves. Once the oven is turned off, the plasma dissipates. But not all metal objects spark in the microwave, though they might make things cook a little unevenly. In fact, a lot of microwavable packaging takes advantage of this, using a thin metal coating to crisp the food surface. And overall, as long as it does approach the oven's bowl, leaving the metal spoon in a microwaving bowl of soup should be pretty uneventful affair. That's just another neat benefit of cooking with radar.